So what I'm going to talk about now is how to construct the ray diagram for a compound microscope. So what I've done is I've started off by having my two lenses. So again, I've got what we call an objective lens, and again, I've got what we call an eyepiece. The difference being is, as you notice, the object this time, instead of being over infinity, it's much closer. That actually makes our life a lot easier because it's simply just doing two ray diagrams back to back. This is the object in this case. It's in between f and 2f for the objective lens, so that the objective lens can create a real magnified, so that the objective lens can produce a real magnified version of the object here. So we just follow the normal same strategies we would to draw a normal ray diagram. So the first one goes parallel to the principal axis, then it goes through the focal point, then we draw a ray going from the top of the object through the center of the lens, and where they cross is the place where the image has been formed. So the image will have been formed here where the two rays cross. Now we then use this lens to magnify that image, and we just go through the exact same process, right? So consider a ray that is traveling parallel to the principal axis from this this image. Now remember, what happens here is that this image then becomes the object for this lens. So we're magnifying this. So we draw this parallel ray, then that ray gets refracted through the focal point of the eyepiece, just like normal. And then we take another ray that goes through the center of the lens, and as you can see, they're diverging. Now, to find out where the image is produced, we backtrack these rays so that we can work out where the image would be formed. So we take dotted lines, and remember they're dotted because they're not actually real, and where they cross is where the image is produced. So we backtrack these lines, and where they cross is where they're produced. Now notice, crucially, what's different about this to the telescope is that we don't want the image from the first lens to be formed on the focal length of the second, because we want maximum magnification, and for that we need the image to be produced at the near point. So this image here, again, it's virtual, but this time it's not produced at infinity, but the image is produced here, and it's produced at the near point of the eye, which is roughly 25 centimeters for most people. Now that distance in this case, as long as the eye is very close to the lens, is effectively that distance there. So the distance from the second lens to the image is the distance to the near point. So the image is produced here, and this distance here would be D. So slightly different from the microscope to the telescope. That's it.